Have you ever looked up at the night sky, filled with countless stars, and wondered what lies beyond what our eyes can see? We see a beautiful, but limited sliver of the universe. What if I told you there's a way to see the invisible? To peer back in time to the very dawn of the cosmos? That's not science fiction. It's the reality of the James Webb Space Telescope, or JWST, and its secret weapon is something you encounter every single day: infrared light. Today, we're going on an incredible journey. We'll uncover why this invisible light is the key to unlocking the universe's greatest mysteries. Forget what you think you know about telescopes. The JWST isn't just a bigger, better version of Hubble. It's a completely different kind of eye on the universe, and its infrared vision is changing everything we thought we knew about space. By the end of this video, you'll understand how something as simple as the heat you feel from the sun allows us to witness the birth of stars and galaxies over 13 billion years ago. So buckle up, because we're about to look at the universe in a whole new light. First, let's talk about what infrared light actually is. You're already an expert in using it, even if you don't realize it. When you change the channel on your TV with a remote control, that's an infrared signal. When a doctor takes your temperature without touching you, that's an infrared thermometer. At its core, infrared is simply a form of light that falls just outside the range of what human eyes can perceive. Our eyes are tuned to a very narrow band of the electromagnetic spectrum, the colors of the rainbow from violet to red. Just beyond the red end of that rainbow lies infrared. We can't see it, but we can often feel it as heat. Everything with a temperature above absolute zero, which is literally everything in the universe, emits infrared radiation. You, the chair you're sitting on, and even a distant dying star are all glowing in infrared. So why is this heat vision so important for astronomy? Well, imagine trying to take a picture of a bustling city at night, but you can only see the brightest streetlights. You'd miss almost everything: the cars, the people, the glowing signs in shop windows. That's what it's like observing the universe using only visible light. Much of the cosmos is shrouded in vast clouds of cosmic dust and gas. To visible light telescopes, these clouds are like thick fog, completely blocking our view of what's happening inside. But infrared light has a longer wavelength, which allows it to pass right through these dusty veils, almost like they aren't even there. This is where the James Webb Space Telescope comes in. It's designed specifically to be the ultimate infrared detective. Its massive gold-coated mirror, over 6.5 meters wide, is like a giant bucket for collecting this faint, ancient light. Think of it this way. JWST allows us to peek inside stellar nurseries, the cosmic clouds where new stars and planets are being born. With visible light, we just see a dark patch of sky. But with Webb's infrared eyes, the dust becomes transparent, and we can witness the incredible process of star formation in breathtaking detail. We can see young protostars still cocooned in their dusty envelopes, and even the dusty disks around them where planets are beginning to form. It's like having a cosmic ultrasound, letting us see the universe's youngest inhabitants for the very first time. But seeing through dust is only half the story. The other, perhaps more mind-bending, reason for JWST's infrared focus is its ability to act as a time machine. Yes, you heard that right, a time machine. To understand how, we need to talk about the expansion of the universe. Ever since the Big Bang, the fabric of space itself has been stretching, carrying galaxies along with it, moving them further and further apart. Now, think about a light wave traveling through this stretching space. As it journeys across billions of years to reach us from a distant galaxy, the space it's traveling through is expanding. This expansion literally stretches the light wave itself, shifting it to longer wavelengths. This phenomenon is called cosmological redshift. Light that might have started its journey as high-energy ultraviolet or visible light gets stretched so much that by the time it reaches our telescopes, it has shifted all the way into the infrared part of the spectrum. The further away an object, the faster it's moving away from us, and the more its light is redshifted. This means the very first stars and galaxies, the ones that formed just a few 100 million years after the Big Bang, are now so far away and so redshifted that they are completely invisible in visible light. Their light has been traveling for over 13.5 billion years, and during that epic journey, it has been stretched into the deep infrared. Before the James Webb Space Telescope, we simply didn't have a tool powerful and sensitive enough to capture this faint, ancient redshifted light. It was like trying to listen to a whisper from across a continent, but JWST was built for this exact purpose. Its incredibly sensitive instruments are designed to detect these faint infrared signals from the edge of the observable universe. By capturing this first light, Webb is allowing us to piece together the story of cosmic dawn, the era when the universe first lit up. We can finally ask and begin to answer some of the most fundamental questions. How did the first galaxies form? What were they like? How did they evolve into the magnificent spiral and elliptical galaxies we see today, including our own Milky Way? Every image of a distant galaxy that Webb takes is literally a baby picture of the universe. Let's put this into perspective. When you look at the sun, you're seeing it as it was about 8 minutes ago, because that's how long its light takes to reach us. When you look at our nearest neighboring star, Proxima Centauri, you're seeing it as it was over 4 years ago. The Hubble Space Telescope could see galaxies as they were when the universe was a few billion years old, like seeing a picture of a teenager. The James Webb Space Telescope, with its infrared vision, can see galaxies as they were when the universe was just a few 100 million years old. That's like seeing a picture of a newborn baby. It's a revolutionary leap in our ability to observe cosmic history. This power also extends to studying worlds beyond our solar system, known as exoplanets. Many of the most interesting exoplanets orbit small, cool stars called red dwarfs. These stars are much dimmer than our sun and emit most of their light in the infrared. To study these planets and their atmospheres, you need a telescope that is sensitive to infrared light. JWST can analyze the starlight that passes through an exoplanet's atmosphere. As the light goes through, different molecules in the atmosphere like water, methane, or carbon dioxide absorb specific wavelengths of infrared light. By looking at which colors of infrared are missing, scientists can determine the chemical makeup of that planet's atmosphere. This is our best tool yet in the search for habitable worlds and the potential for life beyond Earth. Webb isn't just looking for clues about the past. It's actively searching for our place in the cosmos today. So from revealing the hidden birthplaces of stars and planets inside dusty nebulas to capturing the faint red-shifted light from the very first galaxies, the James Webb Space Telescope's infrared vision is a true game-changer. It's not just an upgrade, it's a whole new sense. It allows us to see a universe that was previously invisible. A universe that is dynamic, complex, and far more beautiful than we ever imagined. The next time you feel the warmth of the sun on your skin or use a remote control, remember that this invisible energy is the same key that is unlocking the deepest secrets of our cosmic origins. The images and data pouring in from JWST are just the beginning of a new golden age of astronomy. We are the first generation in history to be able to see back to the dawn of time. Thank you so much for joining me on this cosmic journey today. The universe is full of wonders, and we've only just begun to scratch the surface. If you found this as fascinating as I do, please hit that like button and subscribe to the channel for more deep dives into the mysteries of space. Don't forget to ring the notification bell so you won't miss our next adventure. What part of Webb's mission excites you the most? Let me know in the comments below. Thanks for watching, and as always, keep looking up.